Hello, everyone, and welcome to Mpumalanga Maths and Science YouTube channel. And today we're going to be looking at Grade 10 June exam, Paper 1, and specifically in Question 2, which is the equations and inequalities. So let's start off in 2.1 by solving for x, where in 2.1.1 we have to solve for x squared minus x minus 6 equals to 0. So this is just a trinomial 2.1.1 x squared minus x minus 6 equals 0. A simple trinomial in grade 10 can be simplified by factorization using the zero law, whereby we say open two brackets and then we put x and x, then we look for the factors of 6, which start from 1 times 6 and 2 times 3, and these two can only give you a negative 1 in here when negative 3 is being added to positive 2. So therefore we're going to have negative 3 and a positive 2. Therefore, according to the zero law, it's either x minus 3 that is equal to 0 or x plus a 2 that is equal to a 0. And x is equals to a positive 3 or x is equals to negative 2. And then we look at the second question, that is the x root of 27 is equals to 81. This is more of an unusual one for grade 10, but 2.1.2 I would expect it in grade 11. But this is the x root of 27, which is equals to 81. Let's see how we can simplify this one. A grade 10 learner would know that, okay, I would have to change these into exponential and write 27 into its prime or its exponential form, which is 3 cubed, and then 81 into its exponential form, which is 3 to the power of 4. Now, rationalization here can happen whereby a learner needs to know that I call this formula the formula or the rationalization what's looking cards overlook ngaphandle in Swati, but it's the exponent on the inside over the exponent on the outside of the root. So therefore this will be 3 to the power of 3 over x is equals to 3 to the power of 4. And then now, since these bases are the same, the two bases are the same, it means the exponents are also the same, and the same means equal. So 3 over x will be equal to a 4, and then when we multiply or when we do cross multiplication, we get that this is 4x is equals to a 3, and divide both sides by a 4. Then we find that the answer would be a x is equal to 3 over 4. Okay, and we go to 2.2, which says 4 years ago, Mangete's age was half the age he will have in 7 years. How old is Mangete now? Now, 4 years ago, we need to have at least maybe a form of an equation whereby we talk of Mangete's age in terms of variable. Now, when we talk of Mangete's age in terms of variable, let's say let Mangete's age be m, that's Mangete's age. So 4 years ago, that's Mangete's age minus 4 years. Mangete's age would be how much? It would be half the age he will have. So in a certain age, so it would be half Mangete's age and the age he will have when in 7 years. So that is plus 7 years to come. So then you simply solve for M as Mangete's age. Now, sorry about that. Now, M minus 4 would be equal to half M plus 7 over 2. And then if we take M minus half M, we get 7 over 2 plus a 4. And this sums up to be a what? Half of M is equal to 15 over 2. Where did I get this 7 over 4 now? Need to erase that. That's a 7 over 2. And then M over 2 basically is equals to 15 over 2. And if I multiply both sides by 2, then I get M is equals to 15. And therefore that means Mangete will be 15. Years old. Okay. And next question is 2.3.1, which is an inequality. Negative 3 less or equal to 1 minus k less than 2. 2.3.1, it's a negative 3 less than or equal to 1 minus k less than 2. Now, to simplify this, we need to make sure that k is left alone here, but k now has a 1 here and has a negative. So we start by the 1. How do you remove a 1? So 1 minus 1 is a 0. So it means we need to subtract 1 in all of these variables within the inequality. Then this is a minus k. I need to erase this so that it doesn't confuse you. Minus k less than 2. Then this is negative 4 less than or equal to negative k less than 2. Now, once we get to this stage, this has formed an inequality, but we want to solve for what? For k, right? We don't want to solve for negative k. We need to divide throughout by a negative 1 or multiply by a negative 1. And when we divide by a negative 1, the sign for the inequality will now change. This will become a 4 greater or equal to k greater than negative 2. That if you write it in the correct format, okay, I made a small teeny tiny mistake here. I did not subtract my 1 here, and if I have subtracted my 1 here, then this becomes a positive 1, and then this would be a negative 1. So you can be able to make mistakes here. This would be a negative 1, such that we rewrite this into a negative 1 less than k less or equal to a 4. Now, the next question is asking us, hence, determine the smallest integer values of k. Smallest integer values of k, that's 2.3.2. 2.3.2, smallest integer values of k. From minus 1 less than k less than equal to 4, the integer values of k are not other than 0, positive 1, positive 2, and positive 3, including 4. But the smallest one here is a 0, therefore k is equal to a 0 if we consider that one. Then we go to 2.4 is solve for x and y simultaneously. And we have y squared minus 9x squared equals to negative 16, and a 3x plus y equals to 8. This equation is what? It's 9, or y, not 9, 2.4 y squared minus 9x squared equals to negative 16, and 3x plus y equals to an 8. Now, a grade 10 learner only knows two methods: the elimination method and the method whereby you use substitution. Now, and to solve this, they do not know that you need to make the y subject of the formula and substitute into the quadratic one. So I will not do that one because that's grade 11, since this video is mainly for grade 10. So I'm going to get straight to it. A grade 10 learner also knows that if I write y squared minus 9x squared equals to negative 16, this is a difference of two squares made by y minus 3x being squared, which is equals to negative 16. And they know how to factorize a difference of two squares, that it becomes a y minus 3x and a y plus 3x, which is equal to negative 16. But let us now look at what have we been given. We were given what? We were given also a 3x plus y equals to 8, which means y minus 3x multiplied by this and this are the same, so it means this is also equal to 8. Then we substitute 8 here, it's equals to negative 16. Then we can divide by the 8 such that we get y minus 3x is equals to negative 2. Then that's our other equation. But we can also now choose to say, let us do the elimination straight away. Say this is y plus 3x equals to 8. And this is equation 1 and equation 2. Then let's sum up equation 1 and equation 2. We will get 2y is equal to 2y plus 0 is equal to 6. Then we divide both sides by 2, and then we get y is equals to 3. Then for us to get the x, we are going to substitute it here, that 3 minus 3x equals to negative 2 would have given us a 3 plus 2 equals to 3x, and this gives us divide by 3 both sides, divide by 3, and then x is equals to a 5 over 3. Or one would have equated the two, made y the subject of the formula from here. If you say y is equals to 3x minus 2, and then y is equals to 8 minus 3x, then I say y is equals to y such that 3x minus 2 is equals to 8 minus 3x, and then 3x plus 3x equals to 8 plus 2, 6x equals to 10, divide by 6, divide by 6, and I get x is equal to 5 over 3. Then I go on to either one of the equation and say y is equals to 8 minus 3 times 5 over 3. Then I get 8 minus 5 is equals to 3. So you can do it in both methods and still get the same answer. That was the substitution in the elimination method. Then in 2.5, which is our last question, 2.5, Given v is equals to pi r squared h, make r the subject of the formula. Make r the subject of the formula. If you're given v is equals to pi r squared h, well, with this one, you can simply say, I want to get rid of everything that is next to the r. But what is next to the r? That's pi times r squared times h. Then I divide by h, divide by a pi here. And I divide by a pi times h. Then I get that r squared is equals to v over pi h. Then I can take the square root on both sides for v over pi h. Then I will get that the answer is r is equals to the square root of v over pi h. Then that's making it by r is the subject of the formula. Last question says that if v is equals to 1,000 cubic centimeters and h is 2.5 centimeters, determine the value of r in terms of pi. So we will not use the value of pi. Sorry about that. We will not use the value of pi, but we're going to apply now. So you can either use in 2.5.2, you can use this formula that you've made, that r is equals to the square root of v over pi h. You have the value of v being 1,000 cubic centimeters and the h being at 2.5 centimeters. So this you substitute as 1,000 over pi and a 2.5. Then you get something like the square root of a 400 over pi. Then this is equals to square root of 400 over square root of pi, which is equals to 20 over square root of pi. Or you can simply do it from the original formula as well by saying this is v is equals to pi r squared h, and then you simply mainly substitute 1,000 is equals to a pi. The r value is just r, and it's squared, multiply by 2.5, divide by the 2.5, divide by 2.5, and then I get something like a 400 is equals to pi r squared, divide by a pi, divide by a pi, and then I get that r squared is equals to 400 over pi. Then I take the square root, I apply it on both sides, and r is equals to the square root of 400 over the square root of pi, which is equals to 20 over root of pi. Thank you for watching this video, and please like, share, and subscribe. See you in the next video. Thank you.